think we can just start. Let's be on time, and thank you very much for joining my session. Yeah, about best practices to make very large updates in Neo4j. And I think our session starts from 4 and should be finished at 4:30. And there's 10 minutes Q&A, and also there's Hunger Game questions you would like to, if you like to answer at the end of this presentation. So first of all, let me introduce myself. My name is Joshua Yu. I'm the pre-sales and field engineering lead in the APAC region. So I'm based in Australia, but currently I'm traveling to China for some customer professional services work. Yeah, unfortunately, because this is online, so I'm not going to go through the room and know each other, but we do have an opportunity at the end during the Q&A session, and feel free to send me any questions in the chat window or send me questions via email anytime after this. Okay, so yeah, interesting about today's session. And here's a question. So have you ever complained or suffered a problem that it is very slow to make updates in Neo4j? And sometimes even worse, Neo4j database just stopped responding, and with like something like Java out-of-memory error. And if that's the case, yes, I think that you're at the right place at the right time. And this is gonna where I'm going to go through these items, subjects. Firstly, to understand how Neo4j handles updates, and what are strategies to optimize updates in Neo4j. Going through a case study with a very limited, or not very, limited resources available on your server, and how to make large enough updates, like tens of millions of nodes updated without having the out-of-memory issues. And more on cipher tuning, and we are going to have Neo4j handles updates in transactions, which means if in one transaction or in one cipher statement, you're trying to make very large updates, Neo4j will store all the interim steps into memory to make sure if the transaction failed, everything can be rolled back to ensure the consistency of the database. So that's the very common idea. You can see my screen, right? If you can't, just let me know. Unfortunately, you cannot yell at me or make any sound, but okay. Right, which means large updates is the larger memory will require. And those memory are actually sitting in JVM heap memory. Remember this, if you have ever used a load CSV from a very large data file, what's recommended always is using periodic commit with a number like 1000. That means every 1000 lines you read from Neo4j reads from the data file, it will do a commit to complete transaction, and then the next 1000, the next 1000. By doing this, you can effectively reduce the size of transaction, the number of updates made within a transaction, and hence to reduce the memory required within a transaction. Great. Okay. So for any other cipher statement, we can use APOC procedure like APOC periodic iterate to do the similar things. Within APOC periodic iterate procedure, there are several parameters you can use. The first one is a cipher query to return a collection of things. It could be a collection of node IDs or a collection of objects, nodes, relationships, path, anything. The second parameter is the cipher statement to update database based on the results returned by the first query. So here, if we return 1 million node IDs, then the second statement will update this 1 million nodes, and the batch size controls the size of transaction. So every 2000 statements, the second statements will be committed, bundled, and committed as one transaction. And also the parallel parameter can define whether we want this to be executed in parallel or in serial or sequential operations. And there is also an iterative list, whether one have the whole list executed as one transaction or not. So by default, this should always be true. Okay, there are a lot of things which can affect the performance of updates. And for example, hardware, mainly disk, what type of disk you are using, monitoring how the memory CPU threads are used within a transaction, updates transaction, execution plan of the cipher statement, where it's most optimized, and is there any heavy operations used within the transaction. Data volume, how big is data? How many nodes or relationship you're updating within one transaction, within a cipher. Parallel processing is enabled or not, also largely impact the results. Query tuning, is the query most optimized? Is there any other space to further tune the query? And other considerations like whether you're running those updates in a single instance of Neo4j or updated in a cluster, which also has a lot of implications. So we'll go through a quick case study using the Stack Overflow datasets. Let me check if I'm still online. Great, okay. Yeah. Stack Overflow database has about 31 million nodes, 78 million relationships, or some hundreds of millions properties. And if you're interested in how to download and import data into Neo4j, here's a link. And the data model of Stack Overflow is very straightforward. There's a post node, there's user node, and there is a green one is a tag node. The user posted a post, and a post has tag, right? And the post can be parent of other posts, or the post can answer another post. So the cipher statement we are to test about how to make large updates is this one. So we match post with ID. We match the users who posted the post. And then we set a property called posted by to be the user ID from the user node. So yeah, that's we just want to test how this cipher updates performs. Yeah, basically we store the user who posted the post, the ID of the user, to the value of the property of post. Does it make sense? Yeah, hope so. And test environment is a laptop basically with a limited 12 gigabytes RAM, and we use the local disk is a mechanical disk. But to compare the performance, we also attached a SSD drive via the USB 3 port. And the key thing here is the Java page cache we allocated 2 gigabytes, and the Java heap is maximum 4 gigabytes. The database size is about 17 gigabytes. Okay, if you have seen this before, in neo4j.configuration file, we can specify the heap size, initial heap size and the maximum heap size, and also page cache. So the page cache is mainly to load contents like nodes, relationships, or index in the memory to improve the read performance. The heap, as I mentioned before, is for keeping all the interim states of transactions and before transactions are committed. The first thing is hardware. How quick is a disk? So because database updates are mostly random IOs, so the performance of random IO, read and write, are pretty important to the whole overall performance. So the comparisons here, basically, even externally attached SSD is much faster than the local mechanical disk. It can be 15 or 150 times faster than the local drive. And the Neo4j Enterprise Edition exposes metrics of how database server is running. And for details about how to configure it, here are the links. So what we're looking at is we check the disk usage and average response time, the read and write speed. If you open the J console, We also check the heap memory usage here, and the number of threads and the overall CPU usage rate. So while we do the test, we monitor those metrics to see how the system resource is used. Okay, let's start with updating 1 million nodes. So that's luckily in this database, the ID of posts are sequential. So from 0 to 1 million, that's 1 million post nodes. We just update them. And while running this, we check the CPU use, the RAM, disk speed, and those kind of things. And one important aspect of Neo4j database is the most efficient method to access any node relationship is by its internal ID, which is accessible by this function ID. So this is the result. To update 1 million nodes with the cipher statement we just seen, it takes about 46 seconds, and the heap memory usage is well below 2 gigabytes, which is good. CPU usage is around 25%, which is also good. And the write speed about 20,000 nodes per second, which is also not bad, not bad. However, when we change here the size of the updates to be from 1 million to 1.5 million, we notice the Java heap memory usage of Java heap memory has increased to 3.5, right? But for 1.5 million nodes, you can still update them within using the cipher, pure cipher. But when we try to update 2 million nodes at the same time, when in one cipher transaction, it failed because the heap memory is out of memory. So in that sense, does it mean if we update the whole data, all of the nodes, which is about 25 million, that will require some number of, here, the calculation is 65 gigabytes of heap memory, but that's not going to happen if we only have that amount of heap memory. Am I still online? Okay, no one complained. Right. Okay, so the secret is to use APOC. Here's how we're going to do it. We're going to use APOC procedure iterate, and we control the batch size to be 2,000 updates in one transaction, and we run the APOC procedures with different batch size and compare results. So batch size is from 2,000 to 20K, and here is the results. And the important thing we look at is Java heap memory. So it's very well controlled beneath our upper limit. So we can see the size, the bigger batch size, the more Java heap memory used, which makes sense. But as long as below the maximum allocated Java heap size, that's all we want. Yeah, here's the if you see them in a graphical way, yeah, it's very well under the limit, and the CPU usage is okay. So basically, in the larger batch size, there are less transactions to commit, but on the other side, if the batch size is too large, actually that might slow down the overall performance. So we pick the 2,000 as batch size, as is based on the maximum throughput it reaches, and also the CPU usage. The other thing we can look at is whether the transaction can be processed in parallel. So we change parallel from false to be true, and we'll run again, which batch size is 4, because the computer has 4 cores, and altogether every transaction still, it's making up 2,000 with 500 each, with 4 cores for to run 4 parallel jobs. So we have a higher write speed, about almost doubled, 55,000 nodes per second updates, and the heap memory usage is within the range. CPU is fine. So we tested different combinations of updates with the 2 million, 4 million, 10 million, 50 million. Everything looks fine. Yeah. We do see if we use parallel processing, it improves performance. But the important thing is we need to be aware of the locking conflicts, which means if if multiple threads, if we run jobs in parallel and multiple threads or multiple cipher statements or multiple processing jobs are trying to update the same nodes or same relationships, there will be locking conflicts, right? Yeah, that's something you need to be aware of and be careful when you use parallel processing. Another thing to consider is query tuning. If in the first cases we return the ID, internal ID of the nodes, which is a long number, if we return the objects, apparently the objects contains more information, bigger data volume, and the CPU usage will be higher. The Java heap memory use also higher than the previous case, with which we only return the ID, which is a long number, in the job. So it takes more time and it takes more memory. So that's something we also need to consider. All right. So the full update altogether, that's the results. And we successfully updated every 26 million nodes, yeah, by using APOC procedures without getting out of memory, without breaking the database service. Okay, so job done. And further, some more words about query tuning. And because once with the hardware, the infrastructure is fixed, and other than adding more memory or CPU powers, how you compose your query is very, very critical, right? So, and sometimes even if using periodic commit, it can still cause out-of-memory error. There can be reasons like, firstly, you are trying to do too many steps, like you have every line of the source data, you will try to make a lot of upgrades or merges or of relationships or nodes. That might cause issues. So what you can do is reduce the number of periodic commit. But the second one is more interesting. If you have an eager operator that will disable periodic commit. And then let's have a look of example. So the eager operation is this definition of the execution plan, but pretty simply, within the eager operation, the cipher statement is going to store all the previous results in memory for the later steps. Here's an example here. Let's say we trying to load the movies database, and here we create the movie nodes, and we keep the movie nodes, and we create person nodes, and finally we return the movie nodes created in the previous steps. So in this cipher, if we explain or we profile the execution, we will see an eager operator here, which means even if we specify this using periodic commit 500, because we need to return a variable defined in the previous step, we have the execution has to keep all the results previously done, and in order to return it at the end. Okay, so that's why there's eager operators. So actually, even if we have 500, the transaction is 500, but the results will be stored, will be kept for the to be returned here. So solutions of this is don't return anything, because since you're updating database, you don't have to return anything if it's not necessary, or you return no property. You can try this in your after this to just return M without the title property. You won't see the eager operator here. Yeah. And also it is all possible to use APOC procedures to do periodic commit by using load CSV. You just embed a load CSV APOC procedure into iterate procedure. Yeah. It's also possible. And also the benefit of this is in cipher statement, you cannot use a variable for your label, the node label or the relationship type. But here you can construct your cipher. You can even specify the movie, the value of a movie, which is labeled from another parameter from a field in your source file. That's the benefits. Another benefit of using APOC procedure to load data. Okay, one last use case is sometimes we need to do a large delete. Like, let's say we want to delete all of the relationship parent of. Here is about 16 million of them. And this is the recommended way. So use epoch periodic.commit, right? You find all of the, you match P through relationship R with R limit 5,000, and delete and return count, which means we delete 5,000 of parent of relationship in the batch, in the transaction. Okay, this all looks good. And this is actually the right way to do things instead of just using match P parent of with R delete R, the pure cipher. Because using pure cipher, you might get the out-of-memory error. But by using periodic commit, you will not have that issue. However, it will do the job to delete 16 million relationships, but it took 8.5 hours. You can test it on your own computer, but on my computer, it took like 8.5 hours. That's roughly 500, a little bit more than 500 deletes per second, and it is not good enough. Can we do better? Yes, of course. So remember the internal ID. The way Neo4j organizes data is all the nodes are stored in a node store, and every node has a fixed width. So is relationships, and that's why the internal ID becomes very useful. It actually is the logical location of the node or relationship in the node store or relationship store. By accessing a node or relationship by its internal ID is the most efficient way, because if the ID is 1, the node for node, then the storage, the address of the node is like from the position of 15 bytes to 29 bytes, right, in the storage. It's a simple math. So let's try the second way to do this. First, let's figure out what's the maximum ID and the minimum ID of the relationship parent of. In this case, it's sequential, very likely, because we import data into the database. Okay, the second step, because there are 16 million of them, second thing is we write a cipher like this. We construct IDs. Yeah, we split them into 1,650 drops, like doing a repeat, by using with range, unwind, call the procedure, periodic commit, to build the ID of the relationship. And we delete, we find the relationship by its ID and delete relationship. Okay, the batch size is 10,000. So if there is there are relationship, but the ID of the relationship is not parent of, we're not going to do anything here. So it's safe, right? And by changing the way we do updates in this way, we actually can have a much better performance. And it actually only takes less than 10 minutes as compared to 8.5 hours on the same machine. That's more than 50 times of improvement. So the key thing here is sometimes we can use internal ID to do updates in a much faster way. Okay, conscious of time, I have to make it quick. The last thing you want to consider is whether you are updating your database in a cluster or in a single instance. In a cluster, if you know how causal cluster works, all database updates in the cluster will be coordinated and sent to the leader node, right? And then the leader node will make sure more than half of the core members, which are the blue dots here on the screen, have committed a transaction, committed updates before the transaction is considered to be committed. So if there's a very large commit or updates, the leader will could become very busy and not able to respond to the messages, communications from other nodes, and other nodes might think the leader is dead, is offline. So other nodes might just do the re-election to become the new leader, which causes the instability of the whole cluster. So the solution here is just make sure the transaction size is small enough. You just change the batch size when you use APOC procedure to make it small enough for each transaction. So the leader will not get too busy to respond to the ping from other nodes, and the cluster can still run stable. Yeah, that's the key, to make sure the transaction size is small enough in the cluster. Okay, summary. But basically, the disk speed is very important. If you use SSD, it's always recommended to use SSD. And if you want to do parallel processing, SSD is the only choice. And the transaction size matters because there is a limit. All transaction, the interim state of transaction are stored in the Java heap memory. And the larger transaction is, the larger memory you will require. And if there isn't enough memory, then you got Java out of memory error, and the database service might be terminated or inaccessible. Using APOC procedures, iterate or commit, you can control the batch size, and also you can control iterate. You can also make transactions parallel, process parallelly. And always recommended to, before you make large transact updates, please make sure you do some tests, understand the profile of your updates. And this is most critical in the production environment. And try to tune your cipher as much further to make sure it's the most efficient. And if you need more help, the community is always there. And also we have training modules like advanced cipher and the graph database modeling and APOC are the good sources for you to have a better understanding. And of course, you can talk to us anytime and through any channel. Okay, I think, let me see if I'm still online. Okay, good, I think. Oh, God. Hello. Okay, thanks. I think everybody's still here. And if you like, you can go to the link at the bottom to answer 3 questions about this session. So from easier, relatively easier to medium to a little bit hard about, so for example, which part of memory does Neo4j use to keep the transaction status? And which of following statement does not allow control of transaction size? And if you observe, the third one might be tricky because we didn't touch too much about the coastal cluster, but you hopefully can figure it out. So if you observe frequent leader re-election in a cluster, which might not be the cause. Yeah, I'm just trying to make this a little bit more tricky for you guys. So if you're okay, you can click the link. Well, sorry, you cannot click the link. Let me give the links to you guys. You can't really click it. The link is here. Yeah, you can use the link to do to finish online quiz. Well, yeah. I don't know how. Yeah, okay, there's questions here. Let me have a look. What's the recommended Java heap memory size as a function of the total available memory? The size of Java heap memory. Okay, I can only tell you it's just the recommended Java heap memory size configuration is based on the database size. Pretty simply, if you have like 1 gigabytes, you can probably just give it half a gigabytes or 2 gigabytes for Java heap memory. If you have terabytes, things if I think when you use the link, I post in the chat window, you should be able to answer the questions data. Okay, I see some questions coming. So basically, but that does not mean that the Java heap memory is the bigger the better, right? For the reason like it's recommended to not exceeding 32 gigabytes, because if over 32 gigabytes, the JVM doesn't handle that part of the memory very efficiently. So if it's over 32 gigabytes, you'd better look at how your cipher is used and or alternatively to use APOC procedures to make your transaction size smaller or in a manageable size. Yeah, I'm more than happy to feel free to send me your query. What cipher you use exactly? Oh my God, the link does not give the questions. I don't know what's happened, but I was told to put this link on the screen. But okay, let's do this. Doesn't matter. So the first one, which part of memory does Neo4j use to keep transaction status? That's very obvious, right? It's heap memory, Java heap, JVM heap memory. And okay, and the second one, which of the following statement does not allow control? The first one, using periodic commit, yes, you can add a number after commit to control the size of the transaction. And the second one, yes, periodic commit, yes, you can. In the params, there's a limit. You can, which is an integer. You can specify the transaction size. Number C is right for these questions, because by simply using match the cipher, you cannot control how big the transaction size will be. So if there's 1 million nodes, this transaction will need to update 1 million nodes. If there's 1 billion nodes, for this one is going to update 1 billion nodes in one transaction, which is not good. So the correct answer for question 2 is C. The third question, if you observe frequent leader re-election in a Neo4j cluster, which item below is not a possible cause? Network communication is interrupted. Yes, if network communication is interrupted, the other core nodes might think the leader is gone or offline, so they will start re-election. So is the leader. A complex graph algorithm is running on a read replica. Yeah, the read replica is actually, logically does not belong to the cluster. So whatever, even if the read replica is offline, will not impact any of the leader or any of the core members of the cluster. So B is correct. Yeah, that's why we have different member types, core and a read replica. Number C, a heavy update statement has been submitted. Yeah, of course, if a heavy update statement has been submitted, it's always handled by the leader. And when the leader becomes, leader as well as the rest of the members, but the leader coordinates the updates. When leader becomes too busy because transaction is huge, or even out of memory, the database service becomes unavailable, every election will be kicked off. Yeah. So for question number 3, B is correct. Yeah, I might stand. Yeah, don't worry about it. I don't know why it doesn't work. Yeah, I apologize. I don't know why it didn't give you the question. Let me have a look. Yeah, so oops. Yeah, interestingly. Anyway, don't worry about too much about like the web technology stuff. Okay. Our large database load takes about 2 days using Neo4j admin import. Okay. If you use import, you need to, if you have a very large database, you need to specify an environment parameter called heap size. And okay, I'll give you an example. Like if you the key thing is you need to have a very large memory if you use Neo4j admin import to load a very large database. Sometimes can be half a terabyte or depends on the data volume. Several billion nodes, okay, several billion nodes, you certainly need a very large database. Very large memory and allocate enough, like 128 gigabytes to heap by specifying an environmental variable called heap_size. The second thing to be aware of when you use Neo4j admin import is the data structure. If it's strictly third normal aligned compliant with, yes, if your data is extracted from a very well designed relational database. Hello. And it's compliant with third normal form, that should be okay. Oh God, what's wrong with the network again? But if you extract your data from a data warehouse which uses like denormalized data, then I would recommend you to transform your data to be normalized, because there will be too many duplicates in the denormalized data, which will slow down your import process. Somehow the network becomes unstable again. Yeah, feel free to send your questions after this to the email address. Let me pop my email here, short.u@neo4j.com, or any of the community members. Because sometimes we need to have a look at your data model, how you model your data and how you load your data. So a lot of things can decide how can make the performance better or worse. Oh God, what's wrong? Let me check if there's any other question in the window. Yes. In a cluster, you need to be very careful when you do large updates. So yes. Yes, when the leader is switched, when the other core members think leader is gone, they will start re-election, and the newly elected leader will try to do the same thing, and then the rest of them might think, yeah, this leader is gone again, so this is just going on and on, and so the whole cluster becomes unstable in this case. So yeah, unfortunately, that's something you probably want to test before what I mean test is to you to run them with a smaller using similar techniques I presented today to decide how big is your transaction in terms of the volume of data to be updated, and oh God, and yeah, to make sure it won't cause any negative impact to the cluster. Let me see if there's any other questions. audience. Yeah, any other question? Feel free to send. Yeah. I don't know how much time we left for this, but yeah, just feel free to.
Hi, Joshua. We probably need to wrap up the session.
Yeah. Where's this one? Okay, I think we are about. I think we